Hi everyone, welcome back. In this video, we are going to build a complete email spam detection model using Python, Google Colab, Hugging Face transformers, and DistilBERT. We will take a pre-trained language model and fine-tune it on our own custom dataset. The custom dataset consists of spam and ham message samples. We are going to use this CSV formatted file having 12,000 ham and spam message samples as dataset. By the end of this video, we will make a spam detector model. So let's get started. Opening Google Colab and changing the runtime to T4 GPU because for transformers it is 8 to 15 times faster than CPU. In the first step, we will install all the required libraries such as transformers, dataset, Scikit-Learn, and accelerate, and optionally connect the Google Drive to this Colab session if the dataset present in Google Drive. Here we are using quite flag so that the installation does not print the installation process. In this cell, we importing Panda to read the CSV file and train test split to split the dataset and dataset for Hugging Face to prepare our data for training. Here using the path of the drive because the dataset present in the Google Drive folders. This is the alternate path if you want to use the dataset from Colab session. We load the CSV using Pandas. The Latin one encoding avoids issues with special characters commonly found in email datasets. Here we print column names and the first few rows to verify that dataset loaded correctly. We rename the first two columns to label and text become different datasets may cause different names, and we remove any two rows that are missing labels or email types. We filter the dataset so it includes only the ham and spam categories. Here we convert the text labels into numeric IDs because the model needs numbers instead of strings. Here we print the size of cleaned dataset and check how many spam and ham messages we have. We split the dataset into 90% training and 10% validation using satisfaction to keep spam and ham ratio balanced. We convert the pandas data frames into Hugging Face dataset objects so they can be used directly with the trainer API. If we run this cell, then we get the output like this. We disable weights and biases logging so that no external tracking starts during training. We import the auto tokenizer, which converts raw text into tokens that the model can understand. We load the DistilBERT tokenizer. This tokenizer splits text into tokens and applies the same processing that the model expects. We define a tokenizer function that takes each text, truncates long emails, and pads shorter ones to fixed length of 128 tokens. We apply the tokenizer function to the entire training and validation datasets using batch equal to true make it faster. The trainer API expects the label column to be named labels, so we rename it. We convert the datasets into PyTorch format, keeping only the required fields, token IDs, attention marks, and labels. Okay, let's run this cell. Then we will get the output like this. Imports required libraries for loading the model, training it, and computing evaluation matrix. Loads a pre-trained transformer model and configure it for a binary classification task like spam or ham, and mapping label IDs to a label names. This defines how models should train, including saving checkpoints in Google Drive, number of training approaches, batch size for training evaluation, learning rate and weight decay, how often to log and save, and using FP16 for faster GPU training and evaluation during training, and automatically loading the best model at the end. If you want to store the training approaches in local Colab session, then use this line. After running the cell, we will get output like this. This defines a custom evaluation function that calculates accuracy, precision, recall, and F1 score from model prediction and true labels. This creates the training object combining the model, training setting, datasets, tokenizer, and metric function to manage the entire training and evaluation process. After running the cell, we will get output like this. This starts model training process using the trainer to run multiple epochs, evaluate periodically, save checkpoints, and load the best model at the end. And it takes 2 to 3 minutes. After completing this progress, the model will be ready. You can see the training was completed. Now we can see the checkpoints folder of the model in the Google Drive. This defines folder path where the trained model and tokenizer will be saved. This is an alternative save location if you want to save inside Colab session instead of Google Drive. This saves fine-tuned model to the target directory. Saves tokenizer files so you can pre-process text the same way during inference. This prints a confirmation message showing where files are stored. After execution, you will see this one. Also, you can see this saved folder in Drive. You can also save these files in collaboration like this. Sets the folder where your trained model and tokenizer are saved. This loads saved tokenizer so text is processed the same way as training. This loads the fine-tuned model from disk. This then puts the model into evaluation mode, important for testing. A list of sample messages to test spam or ham classification. This converts text into IDs and attention masks as PyTorch tensors. This runs model without gradient classification. Gets the predicted class index for each message like 0 or 1. This maps to convert numeric predictions back to labels. And this one print each message and whether it's spam or ham. If we run this cell, then we can see the prediction. Here we can see 2 are spams and 1 is not spam. The model prediction is correct. Now let's change the input. See, there is 2 spam and 3 ham messages. The output have 1 spam and 4 ham messages because the second one is eligible for spam and ham message. The source code link will be given in description and pinned comment. If you found this video is helpful, then please give a like and thanks for watching.